Hi all, and welcome to this next video in my pre-calculus and algebra series. This particular video is a continuation of the previous one. So in the previous video, we had some discussion and then we covered problems 1, 2, and 3 on this problem set. In this video, I just want to focus on problem number 4. And so the problem is up here. A ball is thrown upward and outward from a height of 8 feet. The height of the ball, which we're going to call h of x for height, in feet can be modeled by the function h of x is equal to negative 0.4x squared plus 2.7x plus 8, where x is the ball's horizontal distance in feet. So all right, we have two variables. We have h of x, which is the height, and x, which is the horizontal distance. So if we're going to look at this graphically. And so we have two axes. We have the x-axis and we have the y-axis, right? So the x-axis is horizontal distance and the y-axis is height. So let's just think about this h of x. What does it look like? Well, we know it's a parabola, right? Because we've been discussing parabolas. They are the graphs of quadratic functions. This is a quadratic function because it's a polynomial where the highest power is 2. And let me use a different color than yellow because of this negative sign. Because of that negative sign that I just highlighted green, we know the parabola is going to be pointed in the downward direction. Okay, so we're going to have a parabola, something like this. Don't know where it is, but we know it's going to be pointed down. Now, let's think, what do we know about this parabola just from the context of the problem? Well, go back to the first sentence. A ball is thrown upward and outward from a height of 8 feet. All right, so it's starting at 8 feet. Remember, the y-axis is the vertical height. So if we go up here, 1, 2, 3, 4, 5, 6, 7, 8, this is where the ball is starting, right? And the parabola is going to be like the physical path of the ball. It's thrown upward and outward. So the ball's going in that direction. And then think about what happens to a ball if you throw it, right? Not in a math setting, but in life. You're standing in a field, you throw a ball. It doesn't go up forever and leave the Earth's atmosphere. It goes up and then it comes back down. And then it, at some point, hits the ground. Right, so our parabola is going to look like that. Now, I have the XY plane drawn, in this sort of the standard way we see it. But well, this part of the y-axis down here, that would be negative height. That would be negative height because the vertical axis is height. And there's no such thing as negative height, so we don't need this part of the y-axis, right? This is all below ground, so we don't need this part of the graph. And then the x-axis, let me go with a different color here. This orange part of the x-axis, that's negative also. That's a negative horizontal distance. And there's no such thing as a negative distance, right? So we don't need this part of the x-axis. So it looks like all we need is that quadrant number 1. This is quadrant 2, where the x values are negative. This is quadrant 3, where the x and the y values are negative. This is quadrant 4, where the y values are negative. Negative numbers don't make sense for this particular problem because there's no negative height, there's no negative distance. So what I'm going to do, I'm just going to get rid of all of this. And let's just redraw just the first quadrant. This is still the x-axis, this is still the y-axis, but we only want positive numbers for x. We only want positive numbers for y. 1, 2, 3, 4, 5, 6, 7, 8. We still know there's a point right here. at 8, and the ball is going upward and outward, right? Again, it's going to take a path. It's going to come down, and somewhere it's going to hit the ground. And so that's what this problem is all about. How high does it get? And where does it hit the ground? So all this stuff down here, this steps 1 through 10. All right, so I'm going to do this problem a couple of different ways. One of the ways is I'm going to be using this guy, the graphing calculator. All right, so we're going to get these answers using the TI-84. I'm also going to use Desmos. So 2 different graphing calculator platforms. If you're only interested in Desmos, you could fast forward through the video, or vice versa. So I'm going to talk about the TI-84 method first, and then move on from there to Desmos. Now you see part A, B, and C in this problem. Right? I have B highlighted bold because I'm on the wrong slide. I got to go back 1 slide to part A. So part A is, what is the maximum height of the ball? And how far from where it was thrown does this occur? That's part A. And then part B we'll get to next. How far does the ball travel horizontally before hitting the ground? And then part C is to graph the function that models the ball's parabolic path. Right? It's not as complicated as it sounds. Once we sort of realize what's happening visually, right? We're not gonna, so let's see, before we do this, what we're basically doing is there's a point right here, and that's 8 on the y-axis because it's starting from 8 feet. And then the ball's going to go up and then come down. So that's a part of the parabola. The parabola goes this way in both directions, but we're not going to be, basically we're only looking at the part of this parabola that's in the first quadrant. So we don't need that. We don't need that. And from what we know about parabolas, their maximum occurs at the vertex, right? Their maximum occurs at the vertex. So this is basically, this problem is saying, here's a quadratic function. What is the vertex? And that's something we've seen before. Here's a quadratic function, and what is the vertex? And then part B, how far does the ball travel horizontally before hitting the ground? The x-axis is the horizontal distance. So part B is looking for this point down here, the x-intercept. Right, so this is, this is a word problem, but if we want to restate this in the simplest form, it's, here's a quadratic function. What is the vertex? What is the x-intercept? Okay, so we've done problems like this, and I've talked through them in my previous videos. We were using sort of doing it out by hand. We have a formula for finding the vertex, the negative b over 2a, comma f of negative b over 2a. For x-intercepts, you plug in 0 for the y value, solve for x. All those methods work. They're just a little bit messy because we have these decimal coefficients. We got a negative 0.4 is the a, negative 0.4 is the a, 2.7 is the b. So plugging those numbers into the quadratic formula, a little bit messy. And then 8 would be the c. All right. So rather than do that, I'm going to use the graphing calculator. And then I'll use Desmos. So these steps over here, 1 through 10, this is how to do it on the TI-84 or any version up until the 84. This works for the 82, the 83 as well. To find the vertex and find the x-intercept. So part A, what we're doing here, these 10 steps, finding the vertex of a parabola, or this is the maximum of any graph, not just parabolas, but for this case, it's a parabola. Finding the maximum, which is the vertex on the graphing calculator. Now notice, I've highlighted step 7 and I've circled step 4. Let me tell you why. Step 4 is optional. Right? Step 4 is optional. The other 9 steps you have to do. And the reason I highlighted number 7, because this process is to find the maximum, which in this case is the vertex. I'm going to skip to the next slide. You'll see the same 10 steps, with the exception number 7, we're using a different option 2. All right, so it's not a different set of 10 steps. It's the same. If I go between these, part A and part B, part A, part B, it's the same 10 steps, with the exception of step 7. We have a different choice. For part A, we're choosing option 4. For part B, we're choosing option 2. I'll show you how both of those work. Okay, so let me pull up again the graphing calculator. Now, step 1, anytime you're working with any graph in the graphing calculator, you have to type in a function, because that is where the graph comes from, right? So the way that we type in our function is right here, this y equals key. Well, the first thing we should do is probably turn this guy on. All right, and then to type in a function, you go to y equals. Right, I've already typed it in to save some time, but I've just typed in exactly negative 0.4x squared plus 2.7x plus 8. Once you type in the function, you could graph it by hitting graph. Now I'm going to go back to the 10 by 10. So this is the standard window. So your graph, if you're doing it, it might look like this. So step 4, which is not always required, right? Step 1, 2, 3, 5, 6, 7, 8, 9, 10 are always required for every time you're doing this process with any function. But sometimes you have to do step 4. Change the window. So you see on my graph over here on the right, the maximum, the vertex, can't see it. So we got to change the which part of the graph we're looking at. So I'm going to go into the window. So step 4, press the window key. And this is saying the part of the graph I'm looking at goes from negative 10 to 10 on the x-axis, and it goes from negative 10 to 10 on the y-axis. So we don't need all those negative numbers. So I'm going to change that negative 10 to a negative 5, and I'll change that 10 to a 15. You could go like 0 to 15, 0 to 20. Just somehow you need to extend up vertically, and I think it also makes sense to get rid of some of those negatives. You could actually put zeros in if you want. But I am doing negative 5 to positive 15. And now when you regraph, not 115. Don't want to do that. Negative 5 to 15. Now when you regraph, we just have a different window. We're looking more into quadrant 1. So right here is the vertex, which is the maximum of this graph. So second trace, so step 5 and 6, that's sort of one step there. Second trace, and that opens up the calc, or the calculate menu. We have to press second because the calc is above the trace key, right? And if we want to find the maximum, well, no surprise here, we choose the option that says maximum, which is number 4. Now, some graphs have multiple maximums, so you have to tell the calculator which one. In this case, there's only one, but you still have to do the same process. Using the arrow keys, start off with the left, move that blinking cursor to the left of the maximum value. Anywhere as long as it's to the left. And then hit enter. You'll see a little arrow appear on the screen. Then you move the blinking cursor to the right. Now it's asking for a right bound. So what we're doing here is we're just specifying which maximum value we're looking for. And then the calculator is asking for a guess. So you move the cursor close to the one you're looking for. Enter again. And there's our answer. All right, the maximum is the y value. The maximum is the y value. So that's the 12.55625. Right, remember, maximums and minimums are y values. The x value is the location where that maximum happens. Right, so for this case, it's 3.3750014. These decimals likely go on a little bit farther or maybe forever. But there's our answer. So let me write these numbers down so we have them on our screen. So the vertex was about 3.375. Let's just be consistent for this problem. I'm gonna round everything to 3 decimal places. 3 decimal places. 12.55. We got 55625, but I'll just round it to 12.556. So max height is the y value. So the question, what is the maximum height of the ball? That's the 12.556. And the other half of the question, and how far from where it was thrown does this occur? That's the x value. Okay, so now let's do this again. Let's solve this problem, part A, one more time. I'm going to use Desmos. On the graphing calculator, it's a 10-step process. On Desmos, it's a 1-step process, so maybe a little bit easier. Let's see, where's Desmos? There we go. Okay, so Desmos also a graphing calculator, just an online platform. So I'm going to type in h of x, just exactly what's on the problem. H of x equals negative 0.4 x to the second power plus 2.7 x plus 8. With Desmos, you could either use your mouse or your finger if you have a touch screen and move the graph around. Zoom in, zoom out. And you could also restrict which part of the graph you want. So let's say I only want well, first let's get our answers. So if I just click on the graph over here, I don't have to follow any sequence of steps, right? I just clicked on the vertex and there it is. Boom, the same 2 numbers we just got. Let me go back to PowerPoint. 3.375, 12.556. Let me go back to Desmos. 3.375, 12.556. Right, so things are a little bit easier on Desmos. So I could go in here and say, I'll use curly brackets. X is greater than or equal to, so I'll use the greater than sign on the keyboard. And then if I hit the equal sign, it turns that into a greater than or equal to. And let's say 0. Close the curly brackets. So now I'm only looking at the part of the graph where x is bigger than 0. We could also get rid of the other part. So actually part B, here's our answer. Click on that. 8.978. That is the horizontal distance. That's where the ball hits the ground, 8.978. So we could also say 8.978 0.978 is greater than or equal to x, and that erases the quadrant 4 portion of the graph. All right, so Desmos, pretty easy. I would say really easy. Type in the function and then just click on the graph. Once you click on it once, the points labeled. And so that's exactly what we would get from the graphing calculator. And that's exactly what we did get from the graphing calculator. Okay. So back to the problem. So now for part B, so I'm going to advance to the next slide. Part B, how far does the ball travel horizontally before hitting the ground? Well, we just got that answer on Desmos because it was sort of all in one step. The ball goes up, comes down, hits the ground. So back to Desmos one more time. 8.978 feet. 8.978 feet. So that's the point 8.978, comma 0. So now let's do this on the graphing calculator. It's the exact same sequence of steps. All 10 steps are the same except number 7. We're just going to choose a different option. Ooh, where'd my calculator go? There we go. We're just going to choose a different option. So turn the calculator on. We already have the function in, y equals, hit graph. The window's already changed. There's our graph. The only difference is instead of looking for this point up here, the vertex, we're looking for this point over here, which is the x-intercept. The word we're looking for x-intercept is the 0 of the function. The calculator calls it a 0. Zeros are any solution you get when you plug in 0 for y and solve for x. And if it's a real number, it's going to be an x-intercept on your graph. So second trace, the only difference here, we're choosing option 2, which is 0. Option 2 is what we use for x-intercepts. So this blinking cursor is already to the left, so I'll just hit enter. Then we got to move this. I'll just hold the button down. Okay, there we go. We're a little bit to the right. Enter. Now we're asked for a guess, so move the cursor back close to the x-intercepts you're looking for. Enter a third time, and there we go. If we round that to 3 places, 8.9777, so that's 8.978. And so that's the same. That is the same number we got from Desmos. All right, and I'm going to leave it at that. Part C, already done. The graph. I guess we could draw a graph. All the points are already labeled on Desmos. So there's a point there at 8. All right, there's the vertex, which is up at about 12.5 or so. And 3.375. So somewhere about right there. And then somewhere close to 9 right there. So we could draw this freehand and label those points, or we could just go back to here. So there's our graph. Okay, that's it for this video. I hope this was helpful. I'm including the TI-84 and Desmos. I much prefer Desmos because it's much more efficient. But if you are using the graphing calculator, we could do all those things on there as well. All right. Hope this was helpful.